Good day, geometry. CO35 is the task at hand. Using more proportions to find angles and sides of similar polygons. Kind of really piggybacking what we did in the CO34. We're defining similar figures. We're defining a scale factor. Describe for me, or define similar figures. What characteristics do similar figures have? We kind of compared and contrasted congruency with similarity yesterday. So what do you remember? Yes, Peter.
And that in similar figures was the same shape but not the same size.
Right. So same shape. Different sizes. And what specifically makes them similar? Not every pair of shapes that are both triangles, for example, are similar figures. What makes them similar? Great.
Their angle measures?
Their angle measures are congruent. Okay. Angles are still congruent, but sides are proportional. Okay? Proportional. Right? With congruent figures, their angles were congruent and the sides were congruent. Okay? For similar figures, the angles are congruent, the sides are proportional. An example would be, this pair of triangles here. They kind of look similar. They're not the same, okay? But they're similar. And knowing that they are similar, we can arrive at these conclusions that the angles are still congruent because every triangle has 180 degrees, no matter how big or how small. But the sides are proportional. And anything that's proportional has a scale factor. We've used that phrase already today in correcting the homework. What is a scale factor? Define that phrase. Anyone? Okay. A scale factor is how much bigger or smaller a figure is to another. How much bigger or smaller a figure is to another. Figures with a scale factor of 2 means that one is twice the size. Figures with a scale factor of 1/3 means that one is 1/3 the size. Okay? A scale factor kind of gives you information to compare the sizes of these shapes. Questions thus far? Are we generally liking Unit 5 here? It's kind of a blast from the past as far as all this proportionality and similarity and stuff like that. Okay? So to answer the questions of the figures to the right, write the ratios of corresponding sides. Are the triangles similar? So we talked about corresponding sides, right? They're those pairs of sides in the same position. Let's start with TR. Okay. What's the corresponding side in the other triangle with TR? 15. So one pair of ratios, or one ratio, is 25 to 15. Let's look at RS, which is 20. That corresponds with XY, which is 12. And then looking at TS, which is 30, and corresponding with ZY, which is 18. And by looking at those ratios, how can we determine whether or not they are similar? I mean, they look similar, but we have talked about the dangers of assuming similarity and other things too. How can we determine whether or not these are indeed similar by looking at those ratios made by those corresponding sides? Peter?
Simplify the ratios.
Simplify them down. What does 25 to 15 simplify to be? 5 to 3. What does 20 to 12 simplify to be? 5 to 3, right? Divide both by 4. And what does 30 to 18 simplify to be? Spoiler alert, 5 to 3. Right? So because their ratios all break down to the same simplest form ratio, then They are similar. Okay. What's the scale factor of the figures? How much bigger is triangle TRS than ZXY? Blake?
5/3.
Very good. 5/3. Yeah. The scale factor between these triangles is 5/3. Okay. And that's to say that triangle TRS is equal to 5/3 times the triangle ZXY. Whatever measure you have in triangle ZXY, multiply that by 5/3, and you're going to get that measure in triangle TRS. If we wrote it the other way, if we started with triangle ZXY, how does that scale factor change? Triangle ZXY is what compared to TRS? Will? 3/5. It just flips. Right? Pick a side in triangle TRS, take 3/5 of that, you're going to get that side in triangle ZXY. Okay? So what scale factor you use kind of depends on which triangle you are starting with. How do I get to the other one? Do the perimeters of the triangles have this same scale factor? Show how you know. The perimeter of TRS equals 25, looks like 75. And the perimeter of triangle XY or ZXY, 45. Does that ratio, does that fraction, 75 to 45, simplify to be 5 to 3? Yes, it does. Divide both by 15, and you got 5 to 3. So, who can give me the perimeters of similar polygons? What can we conclude about them? Yeah.
They should simplify to be the scale factor.
Okay. They'll simplify to be the scale factor. Anything else? Essentially that. Okay. The perimeters are proportional and have the same scale factor as the shapes. Riveting stuff, eh?
Yeah.
All right. Questions on it? Okay. And I'll give you a chance to think. Okay. Further on down the page, I've got some good news to share with you. In similar figures, any corresponding segments within the figures, such as what we just talked about, perpendicular bisectors, medians, etc., have the same scale factor as the figures themselves. This symbol here, I don't know if we talked about this here. What does that symbol mean? If you're not sure, you can probably guess based on what we're talking about here, but Will? Similar to. Okay? It's very similar to the congruency symbol, just minus the equal sign, right? Because they're not congruent, they're not the same, they're similar. So this says triangle TPR is similar to XPZ. What is segment PS? Okay, so let's kind of identify these pieces here. TPR is this triangle on the left here. From TS to SR, they are both 6. And then XPZ is the larger triangle on the right. Point Y is the midpoint, 8 and 8. And then PY is 20. What type of segment is PY and SP? What type of segment? Drake? Not a mid-segment. It doesn't go to the midpoint of the same triangle. The mid-segment does. Nathan? Perpendicular bisector. The two clues that you have here, right? It does intersect the triangle at the midpoint, y, 8 and 8, and it intersects at that 90 angle. Perpendicular bisector. Have those two characteristics. So, who can tell me what the length of the PS is? That's ultimately what we're looking for here. And then be prepared to tell me how you know. Take a look at the given information. Knowing that these triangles are similar, we're already told that. That's part of the given. Will?
15.
How do you get that?
6 and 8.
Yeah, knowing these triangles are similar, we don't have to set up a proportion to prove that they are. We can use what we're given outright. We know that those are corresponding sides, corresponding parts. The scale effect here is 6 to 8. So PS, what we're trying to find, we can compare that with 20, or we want to solve it, cross product, simplify, scale factor, or whatever. We end up with 15 as a value for PS. Okay? Anything else? Have I got you excited about similar figures? Well, the good news is that our next objective is another writing objective. Look at all this stuff. You see some familiar friends. You see a side, side, side. You see a side, angle, side. When we talked about those in PO24, they were for congruent triangles. Now we're talking about them in the context of similar triangles. So the side, side, side congruency theorem is different than the side, side, side similarity postulate. Let's start distinguishing between the two of those. Okay? Distinguishing between the two of those. But before we get to that, we get to explore scale factors and such a little bit more. Your homework for tomorrow is. Oh, Gino, you know me better than that.
No.
I'll keep it light. I'll keep it light.
We're gonna get like 15. You're gonna give us 15.
No. 376, 9 through 12, and 14 through 17. I don't know, that might not be the end today. That might be it. That might be.
Why don't we get all of them? Then you're gonna keep it light. Yeah. Light.
How many is that? That's 8 so far?
Yeah.
All right. But you better show your work. Show your work. Show your work. All right, folks, you've got 5 minutes to work. That is how you math. Don't forget to like and subscribe.